Welcome back, my favorite Python programmers, to a brand new video, and in this one we're going to be continuing with the farmer was replaced. We'll be building algorithms that optimize our planting, expanding our farm, and planting new types of entities like pumpkins and trees. The last video did very well. Yes, 27 likes is amazing for my channel, and I'm hoping that this one can get up to 50. So if you like the video, please make sure to leave a like. It makes a huge difference, literally. So thank you for that. Okay, so let's go ahead and get started. Last time we left off with the following farm. So let's take a quick recap. We have discovered 3 different types of things that we can farm. So we have hay, we have wood, and we also have carrots. We've also unlocked quite a few things in our tree. So we still haven't increased the grass yield. We've increased the speed a few times. Actually, we can increase it even more because we have 70 carrots and 100 wood. So let's go ahead and do that. In this video, what I want to do is I want to expand my farm. So first of all, to expand my farm, we will need to unlock the pumpkins, which will require 350 carrots. Interesting. And yeah, I would like to first things first is I would like to expand the farm. That's like priority number 1. Watering, I'm gonna keep that on the side. Variable unlock, I don't know what we can possibly use it for. Now timing, like right here with the debug unlocks, I'm still unsure about that. I feel my goal with this game is first of all to teach you Python whilst having fun, and second of all I also want to get to a point where we have most of the available tools to us, and then we can start increasing the efficiency of our code. Now right here I just wrote this code for YouTube thumbnail. I don't even remember. I think I wanted to make like 1 row of carrots, 1 row of hay, 1 row of something. Anyway, forget about it. So what have we done in here so far? So we farmed hay. Let's go back through what we actually learned. So first thing we unlocked was the while loops, which allowed us to create the while true, which will allow us to go through forever. Which, for example, let's see if I run this. Oh, there we go. If I run this, as you can see, we keep going on forever. Second of all, we created the for I in range get world size. So we also learned about functions that return value, which is the get world size. And by the way, if you're ever in doubt, first of all, or in doubt as in to what this function does or what this does, you also have this nifty index right here. So if I click on it, you can go through anything that we've seen. So for example, the get world size, if you click on it, it returns the side length because this is a square grid, and it returns the size length, which basically says for I in range of the get world, which means we want to go, or I takes in the shape of 0, 1, 2, and 3, right? 3. Back to the camera. 0, 1, 2, 3, which is 4 times, which means this loop is going to go through 4 times, which means we're basically telling it to go through, to do this forever over the size of our grid, and we're checking if we can harvest, we will harvest the hay, and then we move north, which allows the drone to move up. And then once this loop finishes, which finishes right here because of the indentations in Python, then we move east to the right. Now again, there are things that are not super optimized. As you can see, the movement is erratic, but we can also, for example, clear everything where the drone resets, and then we start farming hay. The wood is a bit different because we need to actually plant a bush. So for example, right here, as you can see, we plant a bush, and then once the bush grows, we come back and we start harvesting, and we also check if we can harvest, we harvest and then plant the bush. The carrots, on the other hand, this is just a quick recap, where we do the same thing, where we go on forever over the range, we check if we can harvest, we do harvest, but then we need to check if the ground is soil, because we can only plant carrots if the ground under us is soil. And let me just clear that. So right here for the carrot farming, as you can see, when I run this, this is what it does. It first tills the ground, and we do this by checking if the ground type, which also if I go back into my, let me close a few windows here, it's getting a bit overwhelming. So right here, as you can see, if I check the ground type, you can see that returns the type of ground under the drone. And if we till the ground, it becomes soil. So right here, let me see, where can I find grass, items, hay, entities, carrots, grass. Where is the soil? Grounds. So we have the grasslands where we can immediately start planting our wood. I don't know, honestly, I have no idea what this thing is. I think it's just like hay, wood, I don't know. Anyway, bush. Oh, sorry. We put the bush, we can put it in grassland, but in order to put carrots, we need to have soil, and for that we need to till the ground. And calling the till again changes back to grassland, and that's why we have the if get ground type, which checks the ground under the drone, and then if it's soil, it tills it back. All right, so enough with the recap, let's proceed. So right now, as you can see, the drone goes through the carrots. Whenever it finds that one of them cannot be harvested because carrots take a bit more time, it will just move on to the next one. Now in the unlocks, I want to expand. First order of business is expanding the farm. So that means I need to get the pumpkins, which means I need to unlock the trees. And the trees are actually very interesting, and we'll get to them. We'll get to the trees in just a bit. Let me close the soil. It's very, very interesting, and it will allow us to create an algorithm to solve things. And I want to unlock the pumpkins. So actually, I want to upgrade the to upgrade the carrots yield, I need to have 300 wood. And in order to have 300 wood, I need to start planting trees. So I think, oh, and by the way, carrots, if you notice, like the carrots are increasing, but the wood and the hay are decreasing because carrots require wood and hay. So yeah, as you can see, like things depend a lot on each other. So we're getting into this different world of stuff. And as you can see, now we're gonna stop planting carrots and we'll just harvest all the ones that are available to us. So I think because we are going to, okay, thank you, Mr. Drone. So I feel like I'd like to run this hay farming. Let's see, if I increase the speed, what do I need? Carrots. Let's increase the speed of the drone. As you can see, now it farms hay faster. And I'd like to also start increasing the yield of the hay, just because feels like hay is going to be so important. While our drone is going through his thing right here, let's talk about the trees. So trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Now, this is important. Why? Because you'll notice that we can increase the yield of grass, we can increase the yield of carrots, we can increase the yield of trees, we can even increase the yield of pumpkins, if I'm not mistaken, but we cannot increase the yield of wood. So having trees is important. So let's look at what the conditions for growing trees is. So trees like to have some space, and planting them right next to each other will slow down the growth. The growing time is doubled for each tree that is on a tile directly to the north, east, west, or south of it. So if you want to plant trees on every tile, they will take 2 by 2 by 2 by 2, 16 times longer. So let's read this back. This also is a very important experiment in Python, or in learning Python, because you need to read your assignments and exercises very carefully. So let's look back at this. The growing time is doubled for each tree that is on a tile that is directly north, east, west, or south. So ideally, as we're planting our trees, we don't want to have 2 trees that are adjacent. So if we have a tree, let's say right here, somewhere in the middle, I know the drone is a bit distracting, but like try to focus with me, like right about here, this right here, where my mouse pointer is. So if it's right here, we can't have a tree to its left, to its right, above it, and below it. So immediately you should start thinking like, I should be planting these trees on a diagonal. But unfortunately, our drone cannot move in diagonals. Our drone can only move up or north, south, east, and west. And since we've chosen the direction of going north and then east, we're going to stick with it, and we're going to build our algorithm based on it. And actually, I'm going to show you something that's very nifty, which is going to be the Wacom. And I always use this to help my students understand. All of the instructors do this. If you don't know, I have a Python Teaching Institute. This is a great time to shell out my company, but it's a great service. Anyway, no, it is. We've had fantastic reviews. Anyway, while we're farming hay, by the way, let's increase the yield of hay a few times. All right, there we go. So now, as you can see, the hay yield is 300%, and that's very good. So actually, let me go back right here and let me open the Windows workspace, create a whiteboard. You can't see this, now you should. And let me go ahead because I will want to write some stuff. This is the Wacom, my digital pen. I love using this to explain stuff. Ignore anything that you saw in the previous drawings. Oh, this one has already some designs on it. New whiteboard. Okay. Perfect. All right, so let me show you what I mean. Now, I've already designed something in my previous example. I just want to make sure that there's no wasted time. So let's say we have our farm right here, right? I'm going to draw a square. And I'm going to, how many did we have? 4 by 4. So let's draw 1 line, 2 lines, 3 lines, and I guess that's enough. So let me just make this slightly shorter. Oh no. Seems like we cannot make it shorter. Okay, you know what? Hey, and we are back. I actually found a tool here that is pretty much done what we needed it to do. And I'm going to start numbering these. So remember, we always start at 0. So this is going to be 1, 2, 3, and 4. And this is going to be 0, 1, 2, and 3. Did I say 4? I apologize. Then we're going to set the 2 directions that we need. So we're going to have this, or the horizontal being I, and then going up being J. So what is the reason for all of this? The reason is that we can only plant on these squares right here, right in the diagonal. So these are where our trees are going to be because we don't want to plant right here. Okay? But we could also plant right here. So what is the first thing that you start noticing? First of all, we need to have a for loop, right? A for loop that's going up and a for loop that's going right. So this is how usually you should be sketching. So you should say for example, since we're moving up, I will be us moving to the right. So that is the correct way. We're going to be hopping from 0 to 1 to 2 because we're going up and then we are sliding to the right here and then going up again. So yes, the outer loop will be J, the outer loop will be I, and the inner loop will be J, right? So over the world, I'm not gonna have to write, and this will be like this. I apologize. Right here, this will be, I'm probably going to cut a few things out right here. So remember, I'm just thinking on the fly. I'm trying to figure out an algorithm on the fly. But anyway, we will definitely have an outer loop and an inner loop. Now, let's say we start at 0, 0. This is where we would like to plant. But then we want to check, right? Because notice right here that we are only planting. If we start at 0, the next J that we'll plant on will be right here. So we want to check if J is even, right? If J is even, keep in mind this is not code, this is just me thinking out loud. We will plant. But this is only if I is even. So we have to say if J and I are even, right? Because if J, or if I is odd, like right here, we're planting on where J is odd. Now, Yes. That's what I was thinking was if we're only planting on the diagonal, but in this case, for example, j is different than I, so we're planting on it. So notice, for example, if we take 3, I is odd, which means that we plant on 1 and 3. And that is how we are going to be planting. We're going to check, first of all, we'll create the outer loop to keep track of I. Then we'll create the inner loop, which will keep track of j, so as we're going up. And then we'll say if j is even and I is even, then we will plant our tree, and that way it will be optimized. So this is what we call pseudocode. This is how you solve algorithms. So let's get back into our code right here. As you can see, whoa, we have a lot of hay. Let's just smash this down, right? So we increase the yield of hay a lot. And let's pause this drone because I want to focus. Let's go ahead and create the farm trees. And by the way, I have no idea how long this video is going to be. I just want to get to a certain point and continue. So farm trees, what should we get started with? You know what? I'll just take whatever we had before because this is going to be a while true. And we are going to say for j in range of get world size, and there we go. So let me zoom in, let me move a few things out right here, put this, and let's start working with it. Now I don't know if at some point this might become uneven. That would throw things a bit away. I don't think so, but maybe. Now let's see at how we can plant trees. So if let me see right here. So do trees, by the way, we have the hint, but we don't want to look at it. So if you plant trees on every tile, they will no longer grow. And if I remember, you can just plant them in grass or soil. So there's no need to till. But we do need to check if we can harvest. So we'll check if we can harvest, then we'll harvest, and then we will plant the entity, which is the tree. But before we do that, there is going to be a condition that checks if j and and by the way, how do we check if something is even? That is also very, very interesting. So I'll open this again, and okay, having a bit of time. So we unlocked something, which are the operators, right? Oh, we can just click on, okay, right click. So the operators, and if you look, if we scroll down, we have a very helpful operator that is always used. So this, the modulo. The modulo operator, also known as the remainder operator. So when you divide two numbers, you always have a remainder if you don't have a float. It essentially divides the two numbers and then returns the remainder. So for example, 4 divided by 2, the remainder is 0, because you divide 4 by 2, you get 2, then 2 by 2, you get 0, right? So, but 5 divided by 2, the remainder is 1, because 5, when you remove 2, it becomes 3. Then when you remove another 2, it becomes 1, and you cannot remove 2 from 1 because it becomes negative. So that's the division for you. Just simplifying things. So you can also think of it as repeatedly subtracting. There we go. The right number from the left number until the remainder is less than the right. So if you divide an even number by 2, you get 0. If you divide an uneven number or an odd number by 2, you get 1. So that's what we will use. So we're going to say if j modulo 2 is equal to 0, and by the way, this is another operand. I clicked off too fast. The and right here. Let's go through to show you where the and is. By the way, the comparison is the two equal signs. We've already seen it used. We haven't seen it used before. So the double equal signs means that we're comparing and we're checking if these two entities are equal. And if we have an exclamation mark in equal sign, we're checking that they are not equal. So if I'll tell you more about this, let's just find the and, because with the and, okay, the logic operator is called Boolean. Let's scroll. Can we find an and right here? And evaluates to true only if both values are true. Okay, so right here. I'll just make it smaller. So if j modulo 2 is equal to 0, which means that j is even, and I modulo 2 is equal to 0, then we will check if we can harvest, even though I think we should be checking if we can harvest anyway. Like if the drone gets to a point where they can plant a tree, we should check if it can harvest, and then we harvest and plant the dot tree. You know what? The great thing about Python is that we can just try it, right? And see what happens. So I'm going to clear and let's see what happens, right? Perfect. There we go. But something is missing right here. So we've actually missed something right here. If j and I, so now the next step is going to be elif j is, or modulo 2 is equal to 1, and j and I modulo 2 is equal to 1, which means that they are both uneven, then we will do the following. And by the way, the elif, if you don't know what it is, so first of all, we go through the if the first condition is false, then we go to the second condition or to the elif, and if this condition is true, then we harvest. The else is used when all the elif chain, all of the conditions are wrong on the elif chain. So that means that if j equal to 0 and I equal to 0, if one of these are not true, so if maybe I is uneven or whatever, we will do the following. Again, I'm not sure if this is the most if this is the best way, but as you can see, there we go, we have planted our trees. Now, I always tell students, how do you know if this code is optimized or not? You always have to look at your code, and if you needed to copy and paste, I had to copy this and paste it right here. It's the same exact code, which means that there is definitely something wrong with it. We don't want it to be like this. So we need to change a few things up in here. Let's see.
2 hours later.
Okay, you know what? I just looked at it for a few minutes and I'm like, you know what? Let's just leave it as it is because it's working, right? We have something that's working. Let me clear and let me show you that it's working. Later on, maybe at some point, we will go back and start writing cleaner code. But right now, it's just like we're just getting started. One thing that I would like to fix is this wasted hay. Like, we're not harvesting the hay. We're only harvesting if we can do whatever this is. We want to optimize this because we want to make the ultimate wood farming like file right here. So what I'll do is I'll say if j is not even and I, or one of these is not even, I want to actually rewrite this a bit. I want to say if I modulo 2 is equal to 0, which means I is even, then I'll check if j modulo 2 is equal to 0, then I will plant my entities dot tree. But otherwise, if I is even and j is uneven, else this does not go back automatically, I want to actually plant a bush. So plant an entities dot bush. And then, and I'm not harvesting. I just noticed that I'm not harvesting. So I'll say if can harvest, and then plant this tree. and then, so again, like, I don't like this, like me copying this code and posting it. It hurts me on the inside that I have to copy and paste code. Now, of course, we could create a function, but I feel like there's a better way. Like, this is my instinct telling me that there is a better way. Oh my god. So right here, else, because there's nothing else there's no other value. So if either I is even or it's odd, so right here we'll say, I'll just copy this, which hurts me so much. And this right here should be the same, where we're checking if we can harvest. And right here, if we can harvest, this has definitely got to change, where if I is odd, we are going to check if we can harvest, we'll harvest, and then we'll plant a tree. But right here, sorry, we need to plant a bush. Same as here. And now, I believe we have the ultimate farming file. Boom. Look at that. So tree, bush, tree, bush, tree, bush. How amazing is that? This is really, really, really cool. But this code hurts me. Maybe in the next video, maybe in this one, we will optimize it. But for now, we've just made a perfect simulator. So what can we do? Can we increase the speed, or do we want to expand, or do we want to upgrade the trees? Let's upgrade the trees, and again, and again, and that's it. That's enough upgrading trees. So right now, look at how much wood we are actually gathering, and it will even increase, because notice how sometimes the drone hovers over some of the woods and skips some of the trees just because they haven't grown yet. The water will help us with that, but for now, this is good enough. Next thing I want to do is I want to unlock the pumpkins. So for that, I will stop my trees and I will run the farm carrots. First of all, I will reset everything and run the carrots for a bit. Okay, so we are very close to getting our pumpkins. So in just a few more carrots, let's just, boom, there we go. Now we have our pumpkins. So the pumpkins are also very interesting. By the way, since we finished the trees, let's look at the show. Oh, there we go. This is for the operator, so they can be useful here. Remember that the operator returns the remainder by 2. So this actually uses a function where we have to create our own function. Okay, I mean, it does basically the exact same thing. I'm gonna close it and I'm gonna look at pumpkins. So pumpkins grow like carrots on tilled soil. Very nice. Planting them costs carrots. That's why we keep working on our carrots. And when all the pumpkins in a square are fully grown, they will grow together to form one giant pumpkin. Unfortunately, pumpkins have a 20% chance of dying once they are fully grown, so you will need to replant the dead ones if you want them to merge. Interesting, very, very interesting. So we can make like one huge mega pumpkin. Okay, the yield of the giant pumpkin depends on the size of the pumpkin, so a 1x1 pumpkin. Okay, 1 times 1 times 1. Okay, perfect. So looks like the best thing to do is to plant the ground with pumpkins and then check. And then we'll have to find a way maybe to wait for all of them to grow before we start harvesting. Or we can just go over everything and check below us. If there's not a pumpkin, we plant a pumpkin again. So we'll have to find a way to play around with that. We might optimize it as we go along. But anyway, let's go ahead and start farming pumpkins. So we farm the trees. Again, we will have to get back to this. Farm trees. Let's go ahead and unlock. What did we want to unlock? Pumpkin upgrade? No. Let's go ahead and create a new file, which will be farm pumpkins. Is that how you write pumpkins? Pumpkins, yes, pumpkins. Okay, could I please? And I'm just going to copy all of this because it's basically the same. We need to till the soil, and then instead of carrots, we just plant pumpkins. Okay, now you'll see that this is not good enough because, as our dear friends in the information told us, that it's better to make the pumpkins grow and then harvest them once you have one big mega pumpkin. So let me show you what that would look like. So right now we have a lot of carrots. Let me go back and let's just start farming pumpkins and see what happens. So as you can see, some pumpkins are dying, some are expanding, and then they make one giant pumpkin, which yields more pumpkins than if we were just harvesting them as we're doing right now. Let's see how many we need for the upgrade to expand. We need 200. Okay. So what I want to do, first step, is going to be to, before we move east and start like flipping around, I want to, or going through, actually, I gave myself away there. I want to, once we finish this for loop, I want to for I in range of 5, just do flip. So I'll do like 5 flips, maybe 3 flips will be enough even while waiting for the pumpkins all to grow. So, okay, wait, clear. Let's see, boom, boom, boom. No, that's not what I want. That's not what I want at all. Let's see if I do this. I'm not sure what will happen, to be honest with you. What happens if we're outside of the while loop? Yeah, we'll just never get to the flip. Okay, I apologize for that. That was kind of stupid. If I want to flip before moving on, or once I get to the last part. Okay, you know what? I can just say if. So before I move, or after I move the last time to the east, which means I reset at the beginning, I'm going to check if I is equal to the get world size. Boom. Then I'm gonna just tab, do a few flips. Let me reset. Let's see how that works. So this is, oh look, all the pumpkins are yielding, none of them are dying. And what the heck did I do? Something is not wrong. If, oh, -1. Because remember, when we say range, it's up to, but not including. So the get world size, the I will never get to that actual world size. It will get to the world size -1. I apologize for that. What? Wait. Hey, fellow Python coders, a quick intervention from future Michael. So I basically took the code that was in the loop. I also added the world size to be equal to 4 because there is no get world size. It's only available to us inside of the game. And I commented everything out because I wanted to see what is happening to this I, because like, to be honest with you, this is something that I should have caught very, very quickly, but in the heat of the moment, I was just a bit confused, and I was also worried about how much is being recorded. And anyways, regardless, I want to answer the question, and I wanted to show you what the problem was. So as you can see right here, I just print out the I in the first loop, and then I print out the I in the second loop. I just wanted you to see what was happening, because for some reason I was confused why I was equal to the world size. For some reason I thought that when we exit out, the I is being reset, so it should be smaller than the world size, but things happen differently, so I'm going to visualize. All right, there we go. So I'm going to go back to the first, and this is a very, very helpful tool that I highly recommend that you use whenever you can. So right here, I do next, while for I in range, and print out. So first of all, the I starts at 0, the world size is 4, which is the same length. So we do 1, 2, 3, and then we jump out. And now I is still 3. So the problem was that I should have been keeping track of another variable, which will be solved in just a bit. But as you can see, I is now equal to 3, which is world size -1, which is 4 minus 1, which is 3, so I is equal to 3, and that's why we are going in into the for loop. And the solution for this is going to be a nested for loop, which I just do later on and fix everything with it, and that is why we go in. And also using another I right here is a very, very big blunder that should not happen. So again, look at this. Okay, just wanted to intervene just to avoid any confusion. And you can continue with the video. By the way, like if you're enjoying this content. If you got to this point, leave a comment, tell me that you did, tell me that I'm stupid, and leave a like because it helps out a lot. Thanks. Okay, you know what? I know what we should do. I want to create an inner loop because I feel that it's the while true that's throwing us off. So I'm going to say for j in range of get world size, because just having a while true and just moving on one side, even though it's working, but I think it's throwing a lot of stuff out. So basically what I did is I said while true, which means I want this to go on forever, but now I'm checking for I in range, which is checking the horizontal, and then for j, as we're going up and we're checking if we can harvest, then we till, then we draw, and then everything is gonna work the exact same. So look at this. Nothing should change, if I'm not mistaken. And there we go. Okay, everything is good. That's the most important part. But why is it not planting pumpkins? Is there something wrong? Oh, so if we can harvest, then we harvest, and then we plant the pumpkin only if we can harvest. Let's see if we do this, what would happen. Okay. What I'm worried about is that if we can't harvest, we are immediately planting a pumpkin on top of that, which would destroy it. So what I would say is, while not can harvest, we do flip, and once we can harvest, we do this. Let's see if that. Okay. No, that was stupid of me. Let's just stick with the if. So that was working. So everything was working on that. I don't like the fact that we have this thing right here. There is a problem with this code right here, which I'm not entirely sure of. But before we figure that one out, I want to, first of all, how much do we still need? Okay. I want to, once we are here, I want to, for I in range, or for, I don't know, just num in range of 3. Let's just flip. Do flip. So now the flipping thing, but what I want to do is once I get to this edge right here, I want to flip 3 times while all the pumpkins grow, and then proceed. Okay, and there we go. It's kind of working. So we are harvesting more pumpkins. The only thing is, what I would like to do later on is I would like to, instead of just flipping, I'd like to go through each individual one and plant where we can plant. And I also don't like this right here. Something is fishy. So we have a few things that we will need to fix in the next video. But for now, as you can see, we have pumpkins. I will expand my farm, and there we go. There we go, ladies and gentlemen. How nice is our farm? So we have a bigger farm, and we don't have any more carrots anymore. So let's actually farm this one. That is one huge pumpkin field. one huge just pumpkin. Let's farm some trees maybe, because we want to farm these trees. And look, our algorithm is sound. It's not optimized, but it's sound. Where look at that, it still works perfectly fine because we have trees on the diagonal, as you can see. And there we go, it all works. So we have a lot of trees. I want to increase the speed by having some carrots. Now I'm getting some wood, and I'm gonna get some carrots, and I'm going to continue. But ladies and gentlemen, as you can see, we have finished what we needed to do. We have expanded our farm. We started planting trees. We started planting pumpkins. And again, I don't like everything that we've done today because it can definitely be optimized, but we're at the 44-minute mark, at least the recording. Of course, I'm gonna remove a few stuff as we go along. Maybe I'll add some stuff as well. But yeah, I'm just gonna leave it as it is right now. Everything is working, kind of, but we will definitely need to make some optimizations later on. If you have any questions, you can always let me know. If you like the video, please make sure to leave a like. And yeah, thank you so much for watching. I hope you enjoyed, and I will see you in the next one. Bye bye for now.